Okay, so in this video we are going to have a look at some log equations. So if we look here at part 1, we've been given log to the base 2 of 3x plus 1 equals 2. So first thing I'm going to do with this is take it out of log notation and convert to indices notation. So my base would be 2 to the power of 2 is equal to 3x plus 1. Square that out, I'll get 4 equals 3x plus 1. Like 4 minus 1 equals 3x. You'll get 3 equals 3x. Divide both sides by 3. So x equals 1. And an easy way to double check, just use your calculator. And anywhere you see an x in the equation, just replace it with 1. Okay, part 2, a little bit more work to do. We should bring our log rules into play. We have log of 2x plus 5 to the base 3 minus log of x minus 8 to the base 3 equals 1. So in your log tables you see that we don't actually subtract logs. We divide them, and the reason we can apply this rule is that both of my logs are log to the base 3. So my next line will read log to the base 3. The first one goes on top always. And that equals 1. I've gone as far as I can here, so I'm going to convert to indices notation. 3 to the power of 1 equals 2x plus 5 over x minus 8. 3 to the power of 1 is 3, and I'm going to cross multiply by x minus 8. Multiply out that left bracket, and we get 3x minus 24 equals 2x plus 5. Numbers on one side, letters on the other. And we get x equals 29. And again, this type of equation you can just pop into your calculator to double check your solution. The same approach as we've seen above and in previous videos. Okay, so if we look now at part 3, we'll see the wording in parts 3 and 4 are slightly different to parts 1 and 2. Same again, we're being asked to solve for x, but they tell us to give our answers corrected to decimal places. So that tells me I'm going to use my my exponential equation approach, but my last couple of steps will be slightly different in the approach. Okay, so we have 2 to the power of 2x minus 8 times 2 to the power of x plus 15 equals 0. I'm going to rewrite that as 2 to the power of x squared minus 8 times 2 to the power of x plus 15 equals 0. I'll let y equal 2 to the power of x. So I get y squared minus 8 times y plus 15 equals 0. Just tidy it up. Okay, so my factors of 15 are 1 by 15, 3 by 5. I'm looking to get minus 8. So it'll be minus 3 minus 5. We have y squared minus 3y minus 5y plus 15. Y times y minus 3 minus 5 times y minus 3 equals 0. Set up our two brackets. And we get y equals 5 or y equals 3. Okay, so we have our two cases. And we had said above that we were going to let y equal 2 to the power of x. So this is where our approach changes. Using the exponential equation approach, we would have 3 is equal to 2 to the power of x, and 5 equals 2 to the power of x. So if we look at both of these left-hand side parts, we cannot rewrite them in terms of 2 to the power of something. So that's where we use log notation. So we get log to the base 2 of 3 equals x. And we just put that into our calculator. So log to the base 2 of 3. So we have x equals, and you'll get back quite a long number. So always write out the number in full before rounding. 62501. And we had been asked to round to 2 decimal places. So we get x is equal to 1.58. There's my first solution, and my second one will be log to the base 2 of 5 equals x, which will give into your calculator 2.32 1928 095. So for this one we get x equals 2.32. Okay, and that's part 3 answered. And now in part 4 we were dealing with 3 to the power of 2x is equal to 24 minus 5 times 3 to the power of x. First thing I'll do is get everything on the one side. And I'll rewrite my first term. So I'm going to let y equal 3 to the power of x, and I get y squared plus 5 times y minus 24 equals 0. Just tidy up. Factors at 24, 1 by 24, 2 by 12, 3 by 8, and 6 by 4. And we need a pair that will give me plus 5, so it's 8 and 3, plus 8 minus 3. So we have y squared plus 8y minus 3y minus 24 equals 0. Set up our 2 brackets. And we get our 2 answers for y. Okay, so we set up our 2 cases. And again, same approach as the exponential equation. We had said y was 3 to the power of x. So we get 3 equals 3 to the power of x. Left hand side I rewrite as 3 to the power of 1. We have a common base of 3, so that will cancel. And I get x equals 1. And for my second one, I have minus 8 equals 3 to the power of x. So for this one here, if we're going to use log notation, it'll be log to the base 3 of minus 8 equals x, which if you attempt to put into your calculator log to the base 3 of minus 8, it will give back a math error. So we're going to put an x, and that we cannot solve. So the condition for logs is whatever the value in here is in your log tables, they usually call it x, it has to be greater than 0. Otherwise, it cannot be calculated. Okay, and that's parts 1 through 4 done for log equations.